So we at Vectra are all about understanding and being able to recognize a cyber attack. So the kind of setup that we were talking about earlier on, we really care about that SSL layer. We care about getting visibility everywhere. And our job in life is to make sure these styles of attacks don't happen anymore, right? So, and we don't put these up there just to like talk about the bad things that have happened. The thing that is interesting here is that all these attacks more or less happened in the same way, right? So when you see one or two attacks like this, it's a learning event. When everybody's kind of falling to the same type of approach, that means that the industry is really missing out on something. And this is what we talk about as the attack lifecycle or the kill chain. You've probably seen something similar to this, but the thing that all of those attacks share in common is that they start out here with an initial infection. Whether it's by phishing, you go to an infected site, whatever happens, they get that first foot in the door. But that's really just the opening gambit, right? After that, they want to get deeper into your network. They want to spread. So if they're going to spread, they need to learn, okay, what else is around me? I need to do some reconnaissance. I need to move laterally because I want to get deeper and deeper into the network and get to places that really matter. And eventually, I want to actually acquire data and exfiltrate it out of the network, right? That's how these attacks run. So the way that these attacks happen, and one of the reasons that there's a gap, is that there's been a lot of investment on this prevention phase, trying to identify that initial infection, trying to look for some known command and control. And you got lots of devices, firewalls, IPSs that do good work there. During the active phase, which is when all of those phases that we were just talking about, the reconnaissance, the lateral movement, the remote access, all of those things are relatively unaddressed. And then you have, once your data gets identified out in the wild, maybe the FBI calls you up and says, hey, we found your credit card numbers on an underground exchange, then people start looking into their SIM database and trying to figure out what happened. This is the security gap that we address. We are all about automating the detection of an attack while it's still active, looking for all of these phases, okay? So a little bit about how we do this. We start out by making sure that we look at all traffic. And this is where our partnership with A10 really becomes powerful, because we want to look at all of the traffic going north, south, east, west. If you hide from security in any way, and attackers do, then that limits what you're able to see. So we want to make sure we're starting out with full visibility. We're looking at everything north, south, east, west. Then how do we go about detecting these bad things? First, we want to not just use something like signatures that are easy to evade. We want to look at things behaviorally. We want to look at what is the actual action that's causing these bad things to happen. And once we find them, we want to prioritize it, put it in a way that you can actually make use of in real time. So if you know to go to look in your SIM and make a certain query because you already know you have a problem, that doesn't help you that much. We want to solve this and identify it for you automatically. So that's really what we do. And I want to give you an example of this. We've looked at some malware in the not too distant past, and it was using command and control. It was using Gmail as its command and control channel. Now, it was able to send communications to the bot-infected machine, all going through Gmail. Now, think about how you write a traditional signature for that, okay? This is an approved valid URL. It's an approved IP range. It's an approved application and port. What do you write as a signature to look for this bad behavior, right? This is something that's incredibly hard to identify with traditional means. We apply our brain to this problem, and we're actually applying data science and machine learning to looking at this communication going back and forth. So if you have this command and control via Gmail, you can actually identify this behavior by looking at the call and response. The call and response still to data science looks like pulling instructions. So that's what a bot does. It's kind of this dumb piece of malware on the inside, and it's going to ask the remote bot herder, okay, what do I do now? Oh, take a screenshot of the desktop. Great, I'll do that and upload it to you, right? And then what's my next job? And it gets that next instruction. So data science is able to identify this without the use of signatures, right? So that's a good start. We can start to see things that we haven't seen before. But what's even more powerful is if we start to correlate all of these things together. Instead of just saying, all right, I had one event and it was kind of suspicious, It gets very instructive when you start seeing multiple phases of the attack. The internal reconnaissance paired with the lateral movement, paired with the acquisition of data and some custom CNC, which we were just talking about. If you see all those things together, then you know you have a real problem. And that's what the approach of Vectra Networks is all about. This is a screenshot of our user interface. Each one of these dots represents a specific host in your network. So in the background, while we're doing all of this data analysis, we're giving every host in your network a score based on its threat and its certainty. So if we wanted to focus in on this one host here, and he has a pretty high threat and certainty score, this is one of the devices that you'd want to walk in the morning and take a look at. You can really quickly see all the types of detections that are tied to this attack. And drill into this device, you're going to see all of his scores, all of his events, and then get right there to the packet captures. You want to see the real proof, you want to see the nuts and bolts of this attack, they're right there. Okay, so this is how you go from really high level information about what's going on with a breach to give me the nuts and bolts details. And of course, you can get into deeper analysis of what is an internal darknet scan. We'll explain all that for you and again, give you the PCAPs for it. Now, how do we think about this in terms of A10? One of the first things we said early on is that continuous monitoring, being able to see all of the traffic is fundamentally important. And this is where we use A10 because we don't do SSL decryption ourselves. So if there's things that we need to look deeper into the packet for, we're going to use the A10's ability to do that. I also talked a lot about context, okay? We saw one piece of an attack, maybe the lateral movement, and then some acquisition of data. That context is so important. You don't want to miss events. You don't want to have things go behind the dark side of the moon and you can't see them anymore because you want to build that complete picture. So this is how we build and are able to deliver on this ability to make sure we have visibility everywhere. Now, how does this actually work? The Thunder ADC on traffic going on the way out, it's going to decrypt that traffic for us. It gives Vectra the ability to see that traffic in the clear. Okay, we can analyze that, send it back to the Thunder ADC, gets re-encrypted out to the outside world. Server or the client interacts with that out in the internet, comes back decrypted. We can take a look at that return traffic coming back to us and is re-encrypted back onto the end user. Okay, so your end users completely oblivious to all this. You get added security. You get that ability to make sure that you establish and maintain visibility everywhere. Because if you're not doing that, if you're ignoring parts of the network, or you're ignoring traffic, you're going to lose, right? If you have a blind spot that you allow the attacker, then the attackers always gravitate to those places, okay? So that's kind of the quick introduction to both us and Vectra and how we're working with A10 and really powerful stuff. I encourage you guys to talk to the good folks from A10 here in the booth.